Bluetooth Low Energy, or BLE, is a technology that enables devices to communicate wirelessly with minimal power consumption. While developing BLE applications for iOS is often straightforward, Android presents unique challenges. In this video, we'll explore why BLE on Android is considered difficult and guide you through the essential steps to make it work reliably. We'll start by understanding the basics, then dive into scanning for devices, setting filters, and managing scan settings. By the end, you'll have a clear roadmap for tackling BLE development on Android. Developers often find BLE on Android much harder than expected. The main reasons include limited and outdated documentation from Google, low-level APIs that require additional abstraction layers, and device manufacturers making their own changes to the BLE stack. These variations can lead to unpredictable behavior, where an app works perfectly on one phone but fails on another. Additionally, there are numerous bugs, especially in older Android versions, that require careful handling. Understanding these root causes is crucial before starting your BLE project. Despite the challenges, the Android BLE community has produced valuable resources. Stuart Kent's presentation is a great starting point for beginners, while Nordic's guide covers advanced topics. Several libraries such as SweetBlue RX, Android BLE, and Nordic's BLE library help abstract the complexity. If you're looking for a simple solution, the BLES library is recommended. Leveraging these resources can save you countless hours and help you avoid common pitfalls. One of the biggest hurdles in Android BLE development is the variation between device vendors. Some manufacturers, like Samsung, have improved upon Google's BLE implementation, while others introduce quirks that can break your app. This means you must test your BLE app across multiple devices to ensure compatibility. It's not uncommon for a feature to work flawlessly on one phone and fail on another due to these vendor-specific changes. Android's BLE stack is notorious for bugs, especially in versions 4, 5, and 6. Later versions have improved, but issues like mysterious connection failures and error codes, such as error 133, still persist. Developers must implement workarounds and robust error handling to achieve a stable BLE experience. While you may not solve every bug, reaching an acceptable level of reliability is possible with careful coding and testing. First step in connecting to a BLE device is scanning. Android provides the Bluetooth scanner object, which you obtain from the Bluetooth adapter. To start scanning, you call Start Scan with filters, scan settings, and a scan callback. The scanner searches for devices matching your filters and notifies you via the scan callback when a device is found. This process is fundamental to BLE communication and sets the stage for connecting to devices. You receive a scan result, you gain access to the Bluetooth device object and other valuable information. This includes advertisement data, which may contain device names, service UIDs, or even sensor data like temperature. The RSSI value indicates signal strength, helping you estimate proximity. Understanding these details allows you to filter and connect to the right device, making your BLE app more efficient and user-friendly. Crucial tip for BLE scanning is to avoid performing Bluetooth operations inside an activity. Activities are frequently created and destroyed by Android, which can lead to multiple scans or broken connections. Instead, handle Bluetooth tasks in a service or other persistent component. This ensures your scans are stable and connections remain intact, preventing frustrating user experiences. Scan filters help you target specific devices during BLE scanning. If you don't set filters, you'll receive all advertising devices, which can be overwhelming. Filters allow you to search by device name, service UUID, or MAC address. This targeted approach makes scanning more efficient, especially when you're looking for particular devices or device types. Filtering by service UUID is useful when searching for a category of devices, such as blood pressure monitors using the standard blood pressure service UUID 1810. Devices advertise their service UIDs, which indicate their primary function. However, some manufacturers use fake UIDs creatively, so always verify the device's actual services after connecting. This method streamlines scanning for specific device type. BLE devices often use short 16-bit UIDs, like 1810, which are equivalent to full 128-bit UIDs. The 16-bit format is a subset of the 128-bit UID, assuming a base UID. Understanding these formats is important for setting up filters and interpreting advertisement data. Refer to the Bluetooth specification for more details on UID structures and their usage. Filtering by device name is common when searching for a specific device or model. For example, a Polar H7 chest strap advertises its name as Polar H7 391BB014, where the latter part is unique. Unfortunately, Android's filter only supports exact string matching, so you can't filter by partial names. To find all devices of a model, scan without filters and perform substring comparisons in your scan callback. Filtering by MAC address is mainly used for reconnecting to known devices. Sometimes the MAC address is printed on the device's box, which is common for medical devices. While you can combine UUID, address, and name filters, it's rarely necessary in practice. MAC address filtering is a reliable method for targeting specific devices, especially when reconnecting after cache is cleared. Technically, you can combine filters for UUID, device name, and MAC address. While this offers flexibility, most use cases don't require such combinations. However, if your application needs to target highly specific devices, combining filters can help you narrow down results and improve scanning efficiency. Scan settings control how Android scans for BLE devices. You can specify scan mode, callback type, match mode, number of matches, and report delay. These settings let you balance power consumption and scanning speed. For example, low power mode scans intermittently, while low latency mode scans continuously for fast results. Choosing the right settings is crucial for optimizing your app's performance and battery usage. Android offers 4 scan modes: low power, balanced, low latency, and opportunistic. Low power mode is ideal for long scans. Balanced mode offers a compromise. Low latency mode scans continuously for quick results, and opportunistic mode depends on other apps scanning. Most developers use low power or low latency depending on their needs. Avoid opportunistic mode unless absolutely necessary. Callback types determine how often Android notifies you about matching devices. All matches callback gives updates every time an advertisement packet is received. First match callback notifies only once per device, and match loss callback informs when advertisements stop. Typically, developers use all matches or first match depending on their control needs. Stopping the scan after a result mimics the first match behavior. Match modes control how Android determines a match. Aggressive mode reports devices quickly, even with weak signals, while sticky mode is more conservative, requiring stronger signals and more advertisements. Most developers prefer aggressive mode for fast device discovery, but sticky mode may be useful in noisy environments. Experiment with these settings to find what works best for your app. Number of matches setting specifies how many advertisements are needed for a match. One advertisement is usually enough, but you can require a few or the maximum supported by hardware. Most apps use one or a few advertisements for quick discovery. Understanding this parameter helps you balance speed and reliability in device detection. Port delay lets you batch scan results and receive them after a specified time. If delay is greater than 0, Android collects results and sends them in a batch, calling on-batch scan results instead of on-scan result. This is useful when multiple devices are expected, allowing users to choose from a list. However, bugs exist, such as incorrect RSSI values on some Samsung devices when using report delay. Scanning not only finds devices but also allows Android's Bluetooth stack to cache device information. This includes name, MAC address, address type, and device type. Cached data is essential for successful connections, as Android relies on it when reconnecting. Each device gets a small file storing this information, making future connections smoother. However, cache management is crucial for reliability. Android clears the Bluetooth cache in several scenarios: when Bluetooth is toggled off and on, when the phone is rebooted, or when the cache is manually cleared in settings. These events can disrupt reconnections as cached device information is lost. Some manufacturers, like Samsung, handle cache differently, so always check if your device is cached before attempting a reconnection. To determine if a device is cached, retrieve the Bluetooth device object using its MAC address and check its type. If the device type is device type unknown, it's not cached. This information is vital for deciding whether you need to scan again or can reconnect directly. Proper cache handling improves user experience and app reliability. Continuous BLE scanning is a power-intensive operation. While it's necessary for applications like beacon detection, it can quickly drain battery life. Google has implemented measures to limit continuous scanning, such as blocking scans without filters when the screen is off and downgrading scan mode after prolonged scanning. Always use intermittent scanning or limit scanning to foreground activity to conserve power. Recent Android versions impose strict limitations on BLE scanning. Android 8.1 blocks scans without filters when the screen is off, while Android 7 restricts continuous scanning to 30 minutes, after which scan mode is downgraded. Starting and stopping scans more than 5 times in 30 seconds temporarily disables scanning. These rules aim to save battery but require developers to adapt their scanning strategy. Scanning for BLE devices in the background is even more challenging. Google limits how long background services can run, typically killing them after 10 minutes. Developers must implement workarounds, such as using foreground services or carefully managing permissions and Bluetooth state. These restrictions make background scanning complex but necessary for certain applications. BLE scanning requires specific permissions: Bluetooth, Bluetooth admin, and access course location. Additionally, location service must be activated. Access course location is considered dangerous by Google, so user consent is mandatory. Always check permissions before scanning and prompt users if necessary. Proper permission handling is essential for successful BLE operations. Before starting a scan, verify that all required permissions are granted. Use standard Android methods to check and request permissions. If access course location is not granted, prompt the user for consent. Ensuring permissions are in place prevents scan failures and improves user experience. Always check if Bluetooth is enabled before scanning. If it's off, use an intent to prompt the user to turn it on. This ensures your app can perform BLE operations without interruption. Handling Bluetooth state gracefully is a key part of robust BLE app development. Let's look at a practical example of BLE scanning on Android. You obtain the Bluetooth adapter, get the Bluetooth scanner, and start the scan with filters and scan settings. The scan callback receives results, allowing you to process found devices. This workflow forms the foundation of BLE device discovery in Android apps. When a device is found, the scan callback provides a scan result. Extract the Bluetooth device object and use its information to decide whether to connect. You can also access advertisement data and RSSI for further filtering. Efficient handling of scan results is crucial for responsive and accurate BLE apps. If you use report delay, Android batches scan results and calls on batch scan results. This is useful when multiple devices are expected, such as in medical or industrial environments. Presenting a list of devices to the user allows for informed selection, improving usability and accuracy. To maximize scan efficiency, use targeted filters and appropriate scan settings. Avoid scanning without filters as it returns all devices and wastes resources. Choose scan modes based on your app's needs, balancing speed and power consumption. Efficient scanning improves performance and user satisfaction. Managing power consumption is vital in BLE apps. Use low-power scan modes for long-running scans and limit scanning to foreground activity. Avoid continuous scanning unless necessary and always consider battery impact. Implementing power-saving strategies ensures your app is user-friendly and sustainable. Android's BLE behavior varies across versions. Older versions have more bugs and limitations, while newer versions impose stricter power and scanning rules. Always test your app on multiple Android versions and devices to ensure compatibility. Adapting to these differences is key to successful BLE development. Device manufacturers often modify the BLE stack, requiring vendor-specific workarounds. For example, Samsung phones may handle cache differently or improve BLE performance. Always research and implement necessary adjustments for popular devices to avoid unexpected issues. Robust error handling is essential in BLE apps. Handle known bugs such as error 133 and implement retries or alternative strategies. Log errors for debugging and provide user feedback when issues occur. Good error handling improves reliability and user trust. Testing your BLE app across multiple devices and Android versions is crucial. Differences in BLE stack implementations and hardware can lead to unexpected behavior. Comprehensive testing ensures your app works reliably for all users regardless of their device. Using BLE libraries like SweetBlue, RX Android BLE, Nordics BLE library, or Blest can simplify development. These libraries abstract low-level details, handle common bugs, and provide higher-level APIs. Choosing the right library can save time and improve app stability. BLE scanning is used in various applications, from fitness trackers and medical devices to smart home systems and industrial sensors. Understanding your use case helps you choose the right scanning strategy, filters, and settings. Tailor your approach to meet the specific needs of your application and users. Design your BLE app with user experience in mind. Provide clear feedback during scanning, allow users to select devices easily, and handle errors gracefully. Efficient scanning and reliable connections contribute to a positive user experience and app success. BLE apps must consider security and privacy. Always request user consent for location and Bluetooth access and handle sensitive data responsibly. Secure connections and proper permission management protect user information and build trust. Summarize: BLE development on Android is challenging due to documentation gaps, low-level APIs, vendor differences, and bugs. Efficient scanning requires targeted filters, proper scan settings, and robust error handling. Testing across devices and using libraries can simplify your workflow. Always prioritize user experience, security, and power management for successful BLE apps. Now that you understand scanning, the next step is connecting and disconnecting BLE devices. In the following video, we'll dive deeper into connection management, handling disconnections, and ensuring stable communication. Stay tuned for practical tips and code examples to master BLE connections on Android. BLE on Android is a complex but rewarding field. With the right knowledge, tools, and strategies, you can build reliable and efficient BLE applications. Remember to leverage community resources, libraries, and thorough testing. By focusing on user experience and adapting to Android's quirks, you'll create apps that stand out in the world of wireless communication.